Hello, welcome back. So far, we have discussed how to create the project schedule network. We also discussed how to calculate the early start, early finish, late start, late finish. Based on that, we calculated the slack, and then once the slack was computed, we could compute the critical path for the project. So we had a plan as to how we will go about doing the project. However, after any project plan is created, it is almost always that the management will ask for reducing the amount of time required for conducting the project. Even in the most aggressive project plan, the management will request that I require to reduce the time because I want the product earlier. Now, under this circumstance, we have to reduce the time of the project, and that is the process which we know as crashing the project. Now, since the project plan is basically a network, we can also call it as crashing the network. Crashing the project is a technical term for reducing the time required for executing the project. Now, we don't require crashing the project only when the project is initiating. Also, when the project is in execution, it may be the case that we are behind schedule and the customer wants the project to be delivered at particular point of time as per commitment or even earlier than what was committed initially. Under that circumstance also, we have to crash our project from the current state to a state by which we can deliver according to the requirements of all the stakeholders. So crashing a project is a very common requirement in any project management, and we will go through the process how to do that in this particular video. In this video, through an illustration, I will demonstrate to you what is the theory behind crashing the project. Later, we will see in Excel how to do it so that we have the most optimum solution. For my illustration, we will use this project network that you can see on this slide. Now here I have got 6 tasks. You can see here A, B, C, D, E, F. So I have 6 tasks. I have noted down the durations of each task. So you can see the durations of our A is 9, B is 8 and so on. So E is 10 and F is 2. So these are the durations. Now based on this duration, I also have the predecessors which I have not planted here, but the predecessors you can make out from the network diagram that you are seeing here, because you can see that A is the predecessor for B and C, and D has got 2 predecessors in B and C, and similarly E has got a predecessor in C, and F has got 2 predecessors in D and E. So this is my network and these are the durations. Based on this durations and the network plan, I have planted for you the early start, early finish, late start, late finish of all the activities. Now, you can also notice that after the computation of all that, I am able to find out the critical path which passes by this particular route. So this is my critical path for this particular network. Now, I have other information about this project that I can reduce the time of activity A by 6 units, or let's say 6 weeks in this case. So you notice here I have given you the data that activity A normally would take 9 weeks, but I can reduce it by 6 weeks. So if I reduce it by 6 weeks, I have a possibility that I can conduct activity A in a minimum of 3 weeks. That is 9 minus 6 is equal to 3 weeks. Similarly, for the other tasks, I have the amount of time by which I can reduce the activity on this, reduce the duration on this particular activity. So for example, the activity B can be reduced by 5 weeks, and so we have a possibility that we can complete activity B in 3 weeks. So we have the data for all the other tasks as well. However, when we reduce the time on any activity, it always comes with a cost. Because when we are going to reduce the time on a particular activity, we will have other expenses, like we may have to add more resources, or in a IT or in a software development project, we may want to buy additional software which can reduce the time required to produce the software and increase the productivity. So there will be additional expenses. It is never free that I can reduce the time of our activity and get away. So it always incurs a cost. That cost which we incur while we reducing the time of a project or of an activity is called the crash cost. So crash cost is the cost by which we will have to incur in order to reduce the time required for conducting a particular activity. So what we have is, in the initial part of the project, is the normal cost. So we have the normal cost, and after we decide to crash the project, we will have the crash cost. So crash cost minus normal cost divided by the crash time. That is, the crash time is what you're seeing here. That is, if I reduce this activity A by 3 units, then I can finish this activity in 6 units of time. So 3 units is the crash time. So crash time minus normal time. So if I take this ratio, that is crash cost minus normal cost divided by crash time minus normal time, I get the crash slope. So crash slope is essentially the amount of money I required for reducing 1 unit of duration from a particular task. I repeat myself, crash slope is the amount of money I require for reducing 1 unit of time from a particular activity. So what I've given to you here is that the crash slope for every activity is provided. Crash slope of activity A is $3,000. For activity B, crash slope is $3,500 and so on. So if I reduce 1 unit of duration from activity A, I will incur a cost of $3,000. So this is my initial plan, and this is my extra data based on which I can try to reduce the time required for conducting this project. So let's see how we can do that. So now we start the exercise where we will try to reduce the amount of time this project will take. We see that normally this project would have taken 36 weeks, and we want to reduce the amount of time this project will take. So my initial strategy is that I will reduce the amount of time required by activity A by 1 unit, activity C by 1 unit, activity E by 1 unit, and activity F by 1 unit. So I will reduce these 4 tasks time by 1 unit. Or in our case, we are talking about weeks, so it's all 1 week. We are reducing the time by 1 week. Now you may ask me, why did I choose A, C, D, E, and F? This is because A, C, E, and F, these 4 activities are lying on my critical path. You can notice here that the activities A, C, E, and F are lying on the critical path. So when we crash a project, we should always take the tasks which are on the critical path and see if we can reduce the time of these activities. We know that there is no slack on the critical path. So if we reduce the time of activities in the critical path, we will get reduction of time of the overall project. Now, this is also known as the minimum slack rule. So this is known as minimum slack rule. Minimum slack rule says that when we are trying to crash a project, we should take the activities which have the minimum slack and see if we can reduce the time of these activities. So if we are successful in reducing time of the activities with minimum slack, we will get the maximum mileage in terms of reducing the time of the project. So now, after reducing the time of activity A, C, E, and F by 1 unit, I get this particular network where I'm able to finish the project in 32 weeks instead of initial estimate of 36 weeks. So now, having done that, we see that our critical path has not changed. The critical path remains the same. However, the duration of the project is reduced by 4 weeks, but we have incurred a cost. We have incurred a cost of $3,000 for reducing activity A by 1 unit. We have incurred a cost of $4,000 for reducing activity C by 1 unit. And we have incurred a cost of $2,500 for reducing activity E by 1 unit. And also, we have incurred $5,000 for reducing activity F by 1 unit. The total cost comes to $14,500. So, to reduce the time of the project from 36 weeks to 32 weeks, we require additional amount of $14,500. In the first iteration, we saw that the critical path did not change. So the critical path still passes through A, C, E, and F. However, we note that we cannot crash the activity F any further because it has reached the minimum duration what is required to conduct this activity. So we can crash the activities A, C, and E. So this time I reduce the time of activity A, C, and E by 4 units each. So by doing that, I get this network where I am able to complete the project in 20 weeks. In 20 weeks, I am able to complete the project. However, I noticed that now I have 2 critical paths in my project. That is, my project has become much more risky. Also, I have incurred a cost of $52,500. After the second iteration, we saw that we have 2 critical paths. So now we can reduce the time of the activities A, C, D, E, and F. But we saw that F we cannot reduce any further, so F is out of question. So we can reduce the time of A, C, D, and E and check whether our network can be crashed further. But we can reduce the time of activity A by only 1 unit, because right now it's at 4 units and the minimum duration required is 3 units. So I can reduce it by only 1 unit. I reduce the activity C by 3 units. This possibility is still there because right now it's at 10 units and I can reduce it further by 3 uh, units because there is still enough amount of space here. And then I can reduce the time of activity D also now, because D is in the critical path, and also we reduce the time of activity E. After having done that, we see that we get this following network where we are able to finish the project in 15 weeks. However, see that we are also incurring a cost of $74,000. Now, we need to ask the question whether it makes sense to spend $74,000 to reduce the time of the project by from 36 weeks to 15 weeks. Will the project be costing more than what the initial cost just for crashing the project? Is it worth it? There are many such decisions. Also, you notice that we are going about arbitrarily in terms of reducing the time of activities. We do not know whether we are doing it in the most optimum manner to reduce the project's schedule. Also notice that we are noticing that right now all the activities have come on the critical path. That means my project has become very risky. I cannot sleep on any activity right now because I have zero slack on the entire network. So these decisions are not so easy and we cannot go about doing it arbitrarily. So now next what we will do is that we will see how we can compute this on Excel so that we get the most optimum solution. Also add more constraints to ourselves based on which we can make a decision which will be more practical.